Hello friends, myself Frankie Singh, Assistant Professor in IT Department at IMS Ghaziabad University Courses Campus. Today's topic of discussion is insertion in linear array. Firstly, what is insertion? If we have a linear array A in the memory, then insertion refers to the operation of adding another element to the collection A. For example, if we have an array A of length 5, we have 3 elements in that array, but the memory we have allocated to that array is 5. Then if we add one more element to that array, so we can say that we are inserting an element in the array, or we are performing insertion. Insertion means adding an element, so we can add an element at the beginning of the array, in the middle of the array, that means in between the elements of the array, or at the end of the array. Firstly, insertion at the end of the array. When we want to insert an element at the end of a linear array, it is quite easy, because if there is space in the linear array, then we can easily add an element at the end of the linear array. For example, in this diagram, we have an array with name of 5 persons and 3 memory locations vacant. If we want to add a new name at location 6 or index 6, then we can easily add this at index 6. But keep in mind that no element can be added to an array without loss of data if the array is already full. If memory locations that are allocated to array are already full or contains elements in all the locations, then we can't add an element without loss of data. Insertion at middle or beginning of the array. As we have seen, for the insertion at the end of the array, we have to do nothing, just we have to add that element at a location at the end of the array. But if we want to add elements in between or in the beginning, then we have to move the elements to make the location vacant. For example, we have the same array with 5 data elements, contains names of the persons, and we want to insert an element at 3rd index, whereas 3rd location already contains a name Johnson. We want to add a name Ford at 3rd location, so we have to make this location vacant before inserting the new item, new name at this location. Now, how to make this location vacant is to shift all the elements under this location one location forward. For example, we have to shift value at location 5 to 6, then location 5 becomes vacant, then we have to move value at location 4 to location 5, then location 4 becomes vacant, then we have to move value at location 3 to location 4, then only the location 3 become vacant and we can insert our new value at location 3. That means if we want to insert a value at location k, then we have to move all the values from location k to location n downwards, or we have to move the values from location k to location n one index forward. Let's have a look at the algorithm for insertion. Here is a linear array with n elements, and k is a positive integer where we want to insert our new value. So k should be less than equal to n. Now, this algorithm inserts an value item into the kth position of array A. Initially, we take a counter variable whose value is assigned with n, means j is equal to n. Now, when we insert a new element in the array, the number of elements get increased by 1, so value of n is increased by 1. Now we will repeat these step 5 and 6 until we have shifted all the values one index forward. We set aj plus 1 to aj. Initially j is equal to n. If we see in this example, here n is equal to 5. So we shift a5 to a6. We have done already. Value of j is decremented. Now we shift a4 to a5 and we repeat this process until the location where we want to insert the value get vacant. When the location get vacant, we insert the new value at that location and stop. Here's the program for the insertion. Same, we have a array A with values 1, 3, 5, 7, 8. The new value to be inserted is 10. The new position where we want to insert the value is 3. N is the length of the array or the number of elements in the array. There are two variables, I and j. J is used as counter variable and value of I is initialized to 0. Firstly, we print the original array. For lower bound 0 to upper bound less than n, we started a loop and print the original array. Now we increase the number of elements in the array by 1 because after insertion the number of elements will get increased. We started our loop until the value of j is greater than equal to k. We will repeat these steps because the last location we want to get vacant is kth location. We every time at every iteration we value at j plus 1 get from aj. That is, you can say that value of jth index is transferred to aj plus 1 index. Value of j is decremented, and when the location k get vacant, the new item is inserted at that location. After this, we have printed the new array. We can see this as an output. The original elements are 1, 3, 5, 7, 8, which are the original array. But when after inserting item 10 at third location, we will get 1, 3, 5, 10. 0th location, first location, second location, third location, and 7 and 8 are shifted to location 4 and 5. This is all about insertion. Thank you.